Hello students, myself Pankaj Chauhan. I am Assistant Professor in Mechanical Engineering Department, GL Bajaj Institute of Technology and Management, Greater Noida. Welcome to a lecture on Introduction and Types of Governors. This is related to the subject of Theory of Machines. The code of the subject is RME 602 and this course is intended for third year 6th semester mechanical engineering students of Dr. APJ Abdul Kalam Technical University, Lucknow. In this lecture, we will discuss about the introduction of governors, what are the different functions of the governors, different types of the governors, and what is the working of a governor. Speed variation in an engine occurs in two ways. Firstly, in cyclic variation. Secondly, variation of speed over a number of revolutions. In cyclic variation, we can say cyclic variation occurs because of variation in the turning moment of the engine. These variations can be reduced by mounting a suitable flywheel on the shaft. Secondly, variation of speed over a number of revolutions is because of variation of load on the engine. In this case, a governor is mounted, which controls the mean speed of the engine by regulating fuel supply to it. So, what is governor? Governor is a speed sensitive device designed to maintain a constant engine speed regardless of the load variation. In further slide, we will explain the process in detail. So, function of the governors. The function of a governor is to regulate the mean speed of an engine when there are variation in the load. As we have discussed earlier, when there are variation in the load, then we have to use a governor to maintain the mean speed of an engine. For example, when the load on an engine increases, its speed decreases. Therefore, it becomes necessary to increase the supply of working fluid, and working fluid may be different for the different kind of engines. For example, for a hydraulic turbine, the working fluid may be water supply or the water. On the other hand, when the load on the engine decreases, its speed increases and thus less working fluid is required. So the governor automatically controls the supply of working fluid to the engine with the varying load conditions and keeps the mean speed within the certain limits. Types of the governors. The governors may broadly be classified as centrifugal governors and inertia governors. In centrifugal governors, the governors are based on the balancing of centrifugal force on the rotating balls by an equal and opposite radial force known as the controlling force. And in inertia governors, the fly balls are arranged in such a manner that the angular acceleration or retardation of the governor shaft will change the position of these balls. So these are the basic two broad categories, centrifugal and inertia governors. And the point to be noted here that inertia governor gives more rapid response to the effect of change of load, but they are practically difficult to make because of partial balancing of the rotating parts, and therefore centrifugal governors are used widely. So we will discuss centrifugal governors in detail. The centrifugal governors may further be classified as follows. The classification is shown into the slide, that is pendulum type and loaded type. First classification is pendulum and loaded type of centrifugal governors. In pendulum type of governors, there is no load on the sleeve, and the example is watt governor. When there is some load on the sleeve, either in the form of dead weight or either by the help of spring force, then it is known into the two different categories. One is dead weight type governors and another one is spring control governors. So dead weight governors are Porter governor and Powell governors, and spring control governors are Hartnell, Harting, Wilson Hartnell, and Pickering. So these are some different types of governors or the classification of centrifugal types of governors, from which Watt governor, Porter governor, Powell governor, and Hartnell governors are of important governors from the syllabus point of view. Working of centrifugal governors can be understood with this diagram. In this diagram, we can see the different parts of the governor. It consists of two balls of equal mass which are attached to the arms as shown in this figure. The balls are known as governor balls or fly balls. The balls revolve with a spindle which is driven by an engine through bevel gears. The upper end of the arm are pivoted to the spindle so that the balls may be rise up or fall down as they revolve about the vertical axis. The arms are connected by the links to the sleeve which is keyed to the spindle but can slide up and down. The ball and the sleeve rises when the spindle speed increases and falls when the speed decreases. In order to limit the travel of the sleeve in upward and downward directions, two stops S S are provided on the spindle. The sleeve is connected by a bell crank lever to a throttle valve. The supply of the working fluid decreases when the sleeve rises and increases when it falls. When the load on the engine increases, the engine and the governor speed decreases. This results in the decrease of centrifugal force on the balls. Hence, the ball moves inward and the sleeve moves downward. The downward movement of the sleeve operates a throttle valve at the other end of the bell crank lever to increase the supply of working fluid, and thus the engine speed is increased. In this case, the extra power output is provided to balance the increased load. Vice versa, when the load on the engine decreases, it can be understood in the same way. Thank you, students. In next lecture series, we will discuss about the Watt governor and Porter governor derivations and their numerical aspects.